Imagine a cargo ship that goes missing in the Pacific. That ship's captain is you. Although you don't know where you are exactly, two stations are constantly sending your ship radio signals at various intervals and that you are 150 miles away from shore. You attempted to determine your ship's approximate location in relation to those two stations using the information provided, the time difference between the two intervals, and the existence of two stations. You struggled for a few minutes to locate your relative location because you couldn't even remember the high school arithmetic concept. But of course, you stopped being lost in the end. How precisely did you locate yourself? Well, the idea of hyperbolas was utilized. How? Didn't you solve it? Well, as a review, let us discuss it.
What is a hyperbola? Let's take two cones, tips on top of each other, and intersecting the cones is a plane. The part of the cones intersecting the plane is geometrically a hyperbola. By definition, a hyperbola is a set of points with the difference between the distance of these points from two fixed points, the two foci being constant. The innermost points of the hyperbola are called the vertices.
By deriving the distance formula of a random known point of a parabola and the two foci, we would find the standard equation of a parabola to be x squared over a squared minus y squared over b squared equals 1, in which a is the distance between the center and the vertex, and b as the. Now, the standard equation is only assuming that the center is on the origin. If it is not, then we have to apply transition rules so our equation may become the quantity x minus h squared over a squared minus the quantity y minus k squared over b squared is equal to 1. Hyperbolas can be found in many orientations, but the two that we'll discuss are horizontal and vertical hyperbolas. How can we tell if a hyperbola is vertical or horizontal? We can tell by simply looking at the equation. The standard equation represents a hyperbola on the horizontal axis. However, if the y term is above a squared instead of x, then the hyperbola is on the vertical axis.
The transverse axis is the line segment which ends at both vertices. The distance of a vertex from the center is a, which makes the length of the transverse axis equal to 2a. The conjugate axis, on the other hand, is the line segment perpendicular to the transverse axis at the center with length 2b. Together, they form the fundamental rectangle of a hyperbola, which will be used later. Additionally, the distance from a focus to the center is c. Lastly, the asymptotes. The asymptotes are straight lines that the hyperbola approaches as it reaches infinity, yet never touches. We can find these by using the fundamental rectangle. By connecting the opposite corners of the fundamental rectangle, we can determine the slopes of the asymptotes given by the equation y minus k equals plus minus b times x minus h all over a.
Now, were you able to visualize the whole process of how you found your location relative to the two stations? No? Then let us apply what was reviewed. First thing you did was find the difference between the distances of the two stations. From that, you were able to find out the formula of the hyperbola that your ship and the two stations were making.
The equation would be x squared over a squared minus y squared over b squared is equal to 1. Of course, a and b are non-zero values, but let us omit that detail right now. The important thing is that you managed to find out these values, and you know that you are 150 miles offshore. That exact distance gives you the value of y, so what you did was just substitute that value for y, leaving you an equation with an unknown value, x. After finding x, you were able to know your exact coordinates and exactly how far your ship is from both stations. Here's the summary of what was discussed in this video. We learned what defines a hyperbola and its parts, what it looks like as a conic section, and how to determine a hyperbola's orientation. I hope this video served you well, and thank you for tuning in.